Okay, my name's John Dwyer with the USGS Aero Center. It's my pleasure to facilitate this session on operational uses of Landsat data. I'd like to start the session by introducing the panel. From your far left, Curtis Woodcock from Boston University, Martha Anderson from the U.S. Department of Agriculture, Agricultural Research Service, Rick Mueller from USDA's National Agricultural Statistics Service, Dorothy Hall from NASA Goddard, and Randy Wynn from Virginia Tech University. Now I'd like to tell you a little bit how I'd like to facilitate this session. I've got one or two charts just to kick this off and put it in context. Then I'd like to open it up to the panel to give them about 5 minutes to talk to their applications of Landsat data and what are the significant performance characteristics of the system that really enable the success of their applications, or what areas, if negatively impact, could really have adverse effects on that. After the panel comments, I'll open that up to the audience here in the auditorium for their views, comments, and questions, and then I'll open it up to people that may be off-site remotely. For those of you that are off-site, if you're going to use the chat function on the WebEx, please chat to everyone, and be advised that your chat message is showing up on the main screen here. So keep it concise and politically correct. And then I'll go to people that may just be dialing in on the phone and give them an opportunity to comment. After we go through that, we've got a section of very direct questions that we've formulated through some of our initial deliberations with the AST. I'd like the panel to respond first. I'll go question by question, give the panel an opportunity to respond, the audience here in the auditorium, and then likewise the people on remote site. So, next slide, please. Most of this, Del and Dave and Tim kind of covered it, but what we're trying to do is really understand those performance characteristics that are of key importance to the user community. What are your minimum requirements, ideas on where you'd like to see these things evolve, but really trying to facilitate that traceability so that when we're looking at different trade spaces for these different architectural concepts, we can understand that if we remove something, degrade it, enhance it, what applications areas that really may impact. We also, as Del mentioned in his, and Dave, we're constrained by 3 tenets of the program: sustainability, continuity, and reliability. So go to the next slide, please. Now, this is an eye chart, and I apologize, this isn't going to show up very well, but just to kind of lay the context, back in 2012, when the USGS issued its RFI, we went to a number of applications projects in different agencies to look at what projects or programs they had, the information products that they were deriving or trying to develop, and that's what these first 2 columns represent. And then, in terms of the system performance characteristics, we're asking, okay, in terms of spectral requirements, whether visible, near-infrared, shortwave infrared, thermal, red edge, or other spectral band characteristics were needed to enable those applications, as well as something about what they felt the radiometric calibration requirements would be, such as absolute radiometric accuracy, the bit depth, if they had some thoughts on that. The green colors represent what they felt was a required characteristic, and the blue is more of a desirement. So this kind of a framework to start with is some of the key performance characteristics we're looking at. If you go to the next chart, please. The same organization for the applications and the information products, but then we continued with the revisit cycles that were required, whether it was 2-day, 4-day, 8 days, 16, et cetera, and what the spatial resolution requirements were for this as well, and whether these were required attributes or desired. So required would be certainly kind of the minimum, desired as if we could move to enhance something. Now I apologize that these are kind of eye charts, but these will be on the website so that you can access these. We will also have a worksheet out on the website as well that people can access and download, fill out for their given application, and then submit back to us so that we will continue to compile this information. But this is the kind of level of detail that we're starting with. If you remember John's value tree, they kind of stopped at the observatory level. We're trying to break that down further to these more specific characteristics. So when we start looking at the trade spaces to provide explicit system performance characteristics, we have something to work with. And so what I would like to do is now start with the panel, and given what we've captured here to date, a couple questions I'd like them to try to comment on in the course of the dialogue is that, are we capturing some of the right performance levels? Are there things we missed? And we really welcome feedback on that. And so I'd like to start, Curtis. I'd open it up to you.
Am I supposed to be able to see this?
No.
Yes, you have to read all of them.
Okay, thank you. I'm going to make a few comments in the context of kind of the land cover and land use change community, and also a few comments in the context of my role as team leader in the Landsat science team. And from the land cover and land use change perspective, what I'd like to try to get across is that this is a very dynamic time. In what I might call the free data era, since we've sort of gotten past the access question to the Landsat data, we're really going through a whole rethinking of what and how we can do in terms of monitoring the way the surface of the Earth is changing. Because we no longer have to require on kind of limited, a few observations that we can afford. Instead, we can sort of take all that are available and go after producing what I would call a more comprehensive history of the surface of the Earth. And in this context, what we're typically doing is taking virtually all the Landsat data for a place and analyzing it together in a time series sort of approach to try to understand when and where changes have taken place, what kind of changes those are, and can we then eventually attribute those to causes, whether they be human causes or whether they be climate change or whatever they happen to be. And there are some lessons that come from this with respect to observational requirements. For example, we are getting much more benefit now than we ever have from partially cloudy images. In the past, if you look at the history of the use of the archive, it was really only the very best images that were being paid for and getting used. We're now using images that have up to 80% cloud cover and still getting valuable observations from them, because you no longer have to have a single observation for every place at one time. You're happy now to get whatever observations you get at whatever times you get them for individual pixels. And so it's not so much an image-based process anymore as it is a pixel-based process. It's a little bit different way of thinking about the data. But we're now at places getting, for example, as much as 20% of our usable observations out of images that are 50% or more cloudy. And it's a very different sort of perspective than what we've done in the past when we've done this kind of work. So that's, and that feeds a little bit into the Landsat 8 discussion, which I also wanted to take a minute to highlight with respect to some of these requirements as well, because we've had some time now to start working with Landsat 8 data. We had a Landsat science team meeting in October where the focus was trying to understand what the quality and characteristics and benefits of some of the new capabilities that exist in Landsat 8 are. And let me sort of give you my 2 cents on some of this. The first one, which there's a tendency to go unnoticed, and Tim mentioned it, and I was pleased to see it, is that there's more data being collected than at any time in the past. And we focus on this 16-day repeat time. That's all well and good, but if the sensor isn't on every time it goes over, you don't get data every 16 days. And if you look at the history of the collection of the data, there are huge gaps in time as a result of the limited duty cycles of the satellite. And so we're now very close to functionally getting virtually all useful data over land from Landsat 8. And that's a fabulous improvement over what's happened in the past. No change in the orbit or repeat time, but the actual amount of data collected is dramatically different. The other thing that we've never had in the past is the ability to detect thin cirrus clouds in Landsat images. And now that we have got a cirrus band and you can see clearly where all these cirrus clouds are, we're learning what a number of people have been hinting at and believing and worrying about for a long time, and that is that all of our past analyses include a lot of images with a lot of cirrus clouds in them, which degrade the quality of the performance of the analyses. And so the cirrus band is a new capability, is a dramatic improvement in terms of filtering out questionable observations from the kinds of analyses that we're talking about. And then the third point is to get to the actual data quality itself, the dramatic improvements in the signal-to-noise ratio, the radiometric quantization, and that sort of thing. We're starting to see for virtually all the kinds of things that we routinely do with Landsat data, like make maps through image classification and that sort of thing, improvements. Okay? The data is better. We're going to get better results out of all the things that we've routinely done. There are new opportunities associated with some of the new bands and that sort of thing, but just the baseline common things that people routinely do, the change in data quality is finding its way into improved results. And that's, I think, an important lesson as we go forward. So I'll stop there. I think I've used kind of my time, but those are kind of my key points that I wanted to make.
Great, thank you, Curtis. Martha?